All right. So it's time for us to get started with our review. This is the one class that you come prepared with questions and I come prepared with nothing. So I said not quite true. I did come prepared to talk about at before class, all of those types of methods. I have some examples. This is a pretty good site for it. But does anyone have any questions other than that before I get started on something that might take a little while?
What's the format of the exam? Is it gonna be just like short answer?
A lot of short answer. There may be some things like code analysis. You may be asked to write some tests for some code that I provide. Very analytical and short answer related. So utilize the entirety of the sheet of paper that you get. Put as much information on that. You do not, though, need to put the JUnit methods on there. That will be on the exam. So if you need to write tests, I'm not gonna hold you back if you don't have the test types on your sheet of paper. So that, again, that will be on the exam. You don't need to put it on your sheet.
Are we going to be given something of a test and be like, this is a bad test?
Possible. Sure, reasonable.
Is it just gonna focus on JUnit or is it?
Yeah, JUnit is the only thing. The review was the review. I was anticipating that being content from a prior course, not so much content from this course. The first topic that we really covered was JUnit, and it's really the only thing that we've had a chance to get experience with. I can't throw anything from strategy on there because there's a forthcoming strategy lab. I don't want to have you take an exam before you have practice with it and feedback on that practice. So yeah, it's just going to be unit testing. But it was a pretty big unit, so there's quite a bit I can do with it. Yeah. So the idea behind regression testing is that we have some working large-scale project. And large-scale projects evolve over time. The requirements evolve, the code base evolves. So maybe we wrote some tests at some point that guaranteed a certain level of functionality of this application. We make some changes to this in ways that break the old testing or ways that do not guarantee that same level of functionality before. Regression testing is the concept of just running tests that you have already written on code that has since been changed to, again, guarantee that level of functionality. These days, it's mostly automated. We have what's called continuous integration that allows us to map tests onto GitHub commits in a way that says, run our entire suite of tests on every single commit that is run. When we commit, we're changing something about our project, run all of the tests we've ever written, make sure that they still pass. If they don't pass, don't accept the commit. If they do pass, accept the commit as part of the project. And that also allows you to continue to write tests during development as you have the extra time to write those tests. And that can also increase the base level of functionality of your project as you write more and more tests for it. So the kinds of tests you might want to write for something that's going to end up being regression tested is the basic functionality, to say that you don't want to insert code into your project that's going to break the basic functionality of your project. And it's really easy to do, especially if you haven't used the appropriate design patterns. Even if you do use all of the associated design patterns, it's not going to be possible to perfectly make your code 100% extendable in ways that cannot reintroduce bugs. Bugs will be there. It's just a matter of whether you know about them or not.
For being able to improve test code readability, what is the level that we should extract from like a child?
Yeah, so I would like it to be that there is no ambiguity in your test. You should know when you read the test this is what the test does. Wherever there could be any kind of misunderstanding, what does this variable do? What does this test do? When does this test fail? All of these kinds of basic questions that I get asked about a test or the implementation of a test should be clear from the structure of the code. I shouldn't need to read a book to understand what your test suite does. I should be able to tell from running the tests. What didn't work? Why didn't it work? I want to minimize the amount of work that it takes for me to go figure out what went wrong, because all of that work is built into the structure of the test.
What do you mean by how do we flag that a method we write is a unit test?
How do we what, sorry?
How do we flag that a method we write is a unit test?
You just have the @test tag. Yep.
Yeah.
Yep. So now I think I can head into this @before stuff. So this has some good examples. These are the exact types of examples that I would give you as well. So for instance, we have a list that we want to instantiate with every new test. The reason we want to do this is we don't want to use, let's say there's an issue with one of our tests where we don't correctly tear it down and there's an element left in the list. If that's the case, and then I call something that checks the size of the list, and I expect the size of the list to be 0, when in fact the size of the list is 1 because of some other test, that is not good. To make sure that this is not present at all in any of your testing code, you can use the @before and @after. So you can see here the @before, we made an init function that prints to some kind of log. We're going to be starting. So this is the start of a test. Then we instantiate a new array list of type string, and we pass in test1 and test2. So there should be 2 elements in the list every single time we go into some kind of unit test. Tear down, we just do something like list.clear that removes all of the elements. And then we would also see in the debug log that we're done with some kind of test. And what this would look like as we go do it, we can now write a couple of other tests, and we don't need to instantiate the list. We don't need to make a list ahead of this. The first thing we can do is assert equals that there are 2 elements in the list. And that's because all of the code from the @before was run before this test. So we made a new array list and it has 2 strings in it. So before we do anything else, we should be able to see that there are 2 things in the list. And we see that if we run these, we get the startup print, executing another test, tear down, startup, executing test, tear down. So we see that the before and the after are done before and after every single test. Before class, on the other hand, we're only going to execute once before all of the tests. This is useful so that you know, here is all of the setup we need to do in order to run all of these tests. It's not setup we need to do for each test. It's just one thing we need to do once before we run a bunch of tests. So for instance, a database connection needs to be made once before we run a bunch of tests that assume that we have a database connection. We don't want to be connecting and disconnecting from the database after every single test. We really only need to test that once. Connect, run a bunch of tests to deal with the database, close the connection with the database. So that is an example of a time when you would want something that is a before class and an after class, because we only need to make that connection once. If we look at the output, we create the database connection, we run 2 different tests, and then we close the database connection. So the way that I've introduced this is in JUnit 4 terminology. If you add JUnit 5, they've changed the name from at before and at after to at before each and at before all. So before becomes before each, before class becomes before all. So they change the names between JUnit 4 and JUnit 5, depending on which implementation you have or use. You'll need to use different terminology. Lots of legacy systems still use JUnit 4. JUnit 5 was only released a year or two ago. So if you're doing something that's state of the art, you're probably using JUnit 5. For the scope of this class, I will use the JUnit 4 terminology, but just know that there is a difference between JUnit 4 and JUnit 5. The ideas remain the same, even if the names are different. I will not mark you down if you use JUnit 4 terminology or JUnit 5 terminology. I know what both of these mean, so as long as you're using one that represents the correct logic, I don't mind which one you use. But you will see in practice, especially as you go start to write tests in industry, there will be a standard for your company using either JUnit 4 or JUnit 5.
And this will be basically for the after, right?
Yeah,
It's like
yeah, there's after each and after all instead of after and after class.
Do you get more examples of assert error strings?
Yeah. So like expected exceptions. So how did we handle this before? We had some way that we could expect an exception. What did that look like?
Rows and header, I think there's like try catch, some stuff.
Yeah, so that's all within the code. We don't usually want to do that too much in our tests. We can show that we can. There we are. We can show that we're expecting an exception by adding the expected equals at the end of the at test. And then we just say the name of the exception class dot class. This is what identifies a particular class of something from being thrown. So you know that when you have an SRC folder, you have the actual code and you have a class directory as well. This allows you to do things like the name of your class dot class to identify when you do something like call a get class method, it's going to compare something from this class file as opposed to the actual logic of what does this mean or what does it do. So you can have an example test here, expected equals array index out of bounds exception. And then you write code that you expect to throw an array index out of bounds exception. Now, when you get that array index out of bounds exception, the test passes. If you fail to get the array index out of bounds exception, the test fails.
Will we be expected to know the exception and be able to comment it into code? Like, there's multiple exceptions, right?
Yeah,
So
lots of different exception types. As long as you have something that kind of makes sense, I'm not going to look for a very specific exception, but I would say know how to write a test that expects an exception is thrown.
So like we could just memorize kind of sort of that example and that would be enough.
Yeah, this should be enough. And that way, as you get experience or exposure to more and more exceptions, you can just plug and play with, all right, now I know what the exception is, now I can write a test that we haven't really gone over those exception types. So if people haven't seen them before, then I don't expect people to have them memorized because we haven't gone over it.
For the before and after stuff, is it like you do a before F1 method and then you have a 5 F's down, is the after there or in every single
If it's just before and after, you'll do the before first method after, before second method after, before third method after. If it's before class, then you'll do the before class, method 1, method 2, method 3, method 4, method 5, after class. It's a matter of whether it's done once or it's bookending each test.
Would some detriments of like test-driven development be like, you're not as free to write whatever you want, like you just gotta like.
It takes time would be the main detriment that I would say. So it can be easy to get caught in the weeds and write 10,000 tests before you've written a single line of code. In industry, you're gonna have something like a 1-week sprint or a 2-week sprint, and you need to have a certain level of functionality implemented at the end of that 1 week. Ideally, if you're following test-driven development, you write enough tests that it saves you time when you're writing and testing your code so that you can meet that deadline. If you spend 6 out of the 7 days writing tests and 1 day writing code, have you finished writing the code by the time your functionality is due to the client? Not necessarily. So it's just finding that balance between writing enough tests that ensure that basic level of functionality and making sure that you're saving overall debugging time rather than just writing a bunch of tests because they're easier to write than the functionality.
Like inside the bracket, after the app test expected, can we combine another one for the timeout also?
Yes,
So that's gonna be comma separated?
yeah.
In terms of like the test suites, the syntax, how much do we need to memorize all of the like imports? Everything you need to run a test suite?
No, I would not worry too much about the imports. If I ask you to write a test, I'm not gonna make sure that the associated imports are there or not. I'll just make sure that it's localized to that exact test. If I ask you a question like what imports are needed in order to run tests, that's where I would have you report that. But that's also a memorization based thing that I'm less likely to ask you anyway, because
So should we write it down on our paper?
you should know it in case I need you to use it for an example, but I'm not gonna ask you a question where the answer to that question is just the import statement.
Okay.
If I asked you, what are 5 things you need to be aware of when you're writing a test? Something like that, one of the answers to that might be, you need to import these things. And if that's there, then you can just plug and play that syntax directly to answer that question. That would be more along the lines of something that I would ask you that's more generic, where you can apply your knowledge of the imports are needed here to be able to answer that question.
The bad habit of our testing, should it be exactly from the lecture, or can we add anything we think that are bad habits?
You could add some other things as well. I will always critically think about any answer that's put on paper. I'm not gonna assert that everything that is here are the only bad habits from testing. So if I did ask you for a bad habit, you will report something that's not there and it's a bad habit, and I agree with it, full points.
Can you give an example of like a redundant test?
That's a great question. So let's say I want to test adding to a list. I write one test that adds 7 to the list and checks whether the size of the list is 1 and that the element at the first position is 7. I write another test that adds 4, checks that the size of the list is 1 and checks that the first element is 4. Useless. If one fails, the other one's going to fail. If one succeeds, the other one is going to succeed. Each test should have a reason to fail that is independent of the other tests. Now, if you did something like add 7, add 4, check if the size is 2, that is distinct from the others because you're following an add with another add. There might be a reason that the second add fails after the first one succeeds, where you would have a reason to test that. So redundant just means that if it's going to fail, there's some other test. Like if this succeeds, this succeeds. If this fails, this fails. You don't get any new information out of that second test. So why did you spend the time to write it? Every test should have a purpose.
This is just out of my. So in the summary, it says each test should have one assertion at the end. So when we're testing for exceptions, that doesn't have.
Right.
Okay.
Yeah, you're not gonna, I guess you're not asserting for an exception. You're testing for an exception. So in this case, when we say at most one assertion, then it's perfectly okay to write one that has no assertions, just expects that we get an exception. Great point.
So the dot equal assertion and dot equal and dot same, there was a different, one was shallow copy, one was deep.
Yes. Yeah, assert same is gonna say, are these precisely the same object? They could be copies of each other, having exactly the same fields and methods and exactly the same values of those fields. Assert same would fail because they're distinct objects. Whereas if we have two different names for the same object, maybe in two different scopes, you could do something like make an array list, pass that array list by reference to another method. You could then assert that from some global scope, the reference from one scope to the array list and the other scope to the array list is the same. And that would succeed because there's only one list. Two different references to that list, but there's only one list. If we had two different lists that had identical values in them, now assert equals would be true, but assert same would be false. Is that clear? Does that make sense to people?
That's like, could you like, is that like overloaded helper method? kind of thing? With
Not quite. So an overloaded helper would just say we want to be able to call the same logic, but be able to pass different parameters.
Yeah, right. So for one of them, you're just renaming it, but it's still the same thing. For the other one, you're literally creating a new thing, and you're saying that this old thing is not equal to this. new thing.
Right. Sometimes we want to make sure, something like we didn't duplicate this structure. There aren't two copies of this structure floating around. So you would want to assert same that only one copy of this structure exists, even though we have two different names for it. On the other hand, we might want to assert that after we've done a clone of an object, that there are in fact two different objects and not just the same object.
Collaborate well, like helpers and overloading helper methods.
Yeah, so helpers are just like private methods that you would have in code that you don't want the client to interface with. So it's not a specific test, but it allows you to factor out logic that is the same between a bunch of tests. So let's say I wanted to prepare a reasonably large number of objects in a list. So list.add1, list.add2, list.add3, list.add4. I want to make sure that there's enough for some purpose. I don't want to copy all of that between all of the different functions that are going to be testing over a reasonably large list. So instead, I can make a helper method that does this once and then call the helper method from each one of those tests. And that way I'm not duplicating a bunch of different add calls. I only have one method with that information in it, with that logic in it, and I can refer to it in a bunch of different places. We do this a lot as computer scientists. If we find that we're copying and pasting things, that is bad. We could probably have some singular reference point to that logic and factor that logic out of all of those places and just have references to that logic from a bunch of different places. Overloading your helpers is useful if you have, for instance, we use the date example here. Let's see, there it is. We had an add helper that took a date object, and we also split that out into years, months, and days. And so now we can call the add helper and make sure that the add helper is working for the different kinds of calls that you might have. This would allow you to do something like, well, let's actually ask people here, what's the difference between these two add helpers? Definitely the parameters. Is there anything different in the logic? One add helper is calling the other. So if this allows you to factor out the construction of a date object, We pass in the year, the month, the day. This takes this information, constructs a date object out of it, and then can call the add helper with the date. And that way, we're not always preparing when we need this date object. Every time we called this method and didn't have the date object, we'd have to be creating that date object. And that would be repeated logic everywhere that we do that. So we factored this out of the add helper to be able to say, if we don't have that information yet, we can pass in all of the information and make the date object in one helper and then call the other one to be able to do the logic on it. So all of this is, it just boils down to decomposition, writing the fewest number of lines of code in order to accomplish the same logic. Whenever you're doing something the same in a lot of places, find a way to factor it out into its own method. And then you can do things like chain those methods and allow you different paths through this logic. We can just call this add helper if we already have the date object. But if we don't have the date object yet, call this add helper, which calls this add helper and constructs the date object for you. And that way, the outside of this, in the actual test, you've minimized the number of lines that you're actually using. And you call an associated helper without having to worry about any of the logic of constructing a date or doing any of the actual work. It's all factored out for you. And that will make your tests easier to read as well.
That kind of goes back to the redundancy that you're talking about.
Yeah. Other questions?
So there's not gonna be anything about the relationship in UML?
Nope.
right now?
Coming on the next exam. Coming soon to an exam near you. But I want to get you a bit more experience with those before I test you on it. I could test you on memorization-based things like these things that I said in lecture, do you still remember them? But I hate that.
How open are you to questions during the exam?
Very. If there's any confusion whatsoever, I will do my best to clarify that unless that clarification just straight up gives an answer. I will try to find some way to, so yeah, if you have any question at all, I would much rather that you ask and force me to say no rather than hold something back.
If we are creating a test and we do not implement something that you expect us to put, would we be done points? Like an easy exception?
If it's in the question, yeah, always read the question after you've answered it, go back to the question and make sure the question has been fully answered. If I anticipate something like that, but it was not embedded in the question, I can't hold it against you.
So we're gonna be given something like, make a test for this method.
Yeah.
Like Victor.
Yeah. I would give you code and say, write tests for this code. Something like that. And then I can just tell you that the entire image that is this slide is on the exam. So for any test that you would write, you do not need to memorize this and you do not need to put it on your sheet of paper. Save yourself the space, put something else on there.
Because some of the words have this testing, just to like kind of illustrate.
What was the first part of that again?
Or like some of the worst testing habits, I guess you could do.
Worst testing habits, not reading the question. I get at least 3 students on any given test where I become a very angry grader. I growl because I want to give people credit for things. And when someone misreads a question, it's one of the most frustrating things from my perspective because I know you know it and the evidence is not on the page. So I can't give you credit for it and it frustrates me so thoroughly. But yeah, reading the question, asking questions if you have questions, that's always a good thing. Make me say no. or make me say, I can't answer that. More often than not, I will be able to answer it or at least push you in a direction that will get something worth partial credit on the page. Don't leave anything blank. If you don't know it, put a best guess. Frequently that will get a point or two. Don't be afraid to show that you don't fully understand something. Show me the best that you understand something, because I am looking to give you credit. I'm looking for, do you understand something, anything? Whatever is there, I can give you credit for. If you leave it blank, I just straight up can't give you credit for it.
How many points are on the exam in total?
There are 104 total points. I'm grading it out of 100. And then I also take the temperature of the class as the class goes along. I will increase the number of points on future exams if the class struggles as a whole on exams. And I will decrease that a little bit if the class as a whole doesn't. I try to build as much of the curve that I would like to give at the end of the course into the exam structure, into other places in the class where I want to. Obviously, I want people to be successful, but I also want to challenge you. So I take that very seriously with exams. I write fairly challenging exams, but then I also want to give you extra credit and opportunities to make up for it. So exams can be fairly challenging.
Where do you post slides on the Canvas page?
Modules, if you go into the
Oh,
modules, there's
I didn't check the files, like, I didn't.
yes, there's an entire module for all of the slides, and I
Oh,
just continue to add to that. So you
Okay.
should have access to all of the slides and modules.
I'm just up there wrong, please.
With the content you've covered in class, you feel like that is, if we understood it and like we're here, we would be able
Yes.
to pass the exam?
Yeah. I'm not trying to throw you any crazy curveballs. I might show you something like code you have not seen before, but code you should be able to understand given your past experience with Java. Then being able to apply this material to that, if you understand it intuitively, that would be the big thing. Don't spend a ton of time memorizing, because that probably won't help you a ton. Try to understand things at an intuitive level so that you can apply the information that's been given. I'm much more interested in application-based learning, because that's what you're going to remember 5 years from now. I want this exam to actually represent the extent to which you have learned, not the extent to which you have memorized and will forget in 2 days.
Are you open in office hours between classes?
Yes. Even the day of the exam, I will have an hour of office hours between classes and an hour of office hours after the exam in here for tiers. That's a joke. I'm hoping that that's not what actually happens.
So Riley told me to ask you this, how do you describe like a technically bad program, how it would work versus like testing bad habits? That makes sense.
Yeah, I'm trying to make that, logically combine that. So difference between testing bad habits and
And like.
general bad code design.
Yeah.
We actually haven't really covered the bad code design. That's a future. So where we are right now, we've just covered strategy and UML. We're gonna go back to another design pattern, and then we're gonna start talking about bad code design. So I'm not too concerned at the moment about bad code design. More so, one of the good code design things that we've talked about is factoring out as much as possible into helper methods or something of the sort. That's really all you need to know for this exam. But that is a very important question moving forward. We'll have an entire long lecture on different ways that you can make code that smells bad. And there is a ton of ways you can do that. And we'll talk about a lot of that in its own separate unit.
What's the detriment to test-driven development?
So if you're adhering to test-driven development, then you're writing all of the tests before you're writing the code. And usually this is a very good thing. That means that when you go to write the code, you'll have a very good understanding of what could go wrong, because you'll have thought about that already. But you can get caught in the weeds and write a bunch of tests and then not leave enough time for the implementation or debugging the implementation. People might think, if I've written all the tests, there's no way that a bug can arise. So that when a bug does arise, you go, wait, I thought I eliminated all of the time that I was going to spend debugging by writing the tests before I wrote the code. So just trying to make sure that when you have a certain amount of time to have functionality complete, that you are thinking about, I need to write all of the code and write all of the tests. If you're adhering to test-driven development, then you start with the tests. Leaving yourself enough time to develop and debug and verify that it's working is something that comes with a lot of practice.
How do you measure software reliability, just through testing or?
We have quite a few ways of doing it. So let's actually go back to that slide deck, because I think I have a few of them. We can measure it with things like uptime. So you have a software system, like let's say you have an always online game. You can measure how frequently are the servers up for this game. And that would be the reliability of the backend system that collects all of the data, authenticates to make sure that you're logged in. This is 300.01, not 212.01. That's the one we want. Somewhere in here. We talked about it early. Was it in the second slide deck? It was in the second slide deck. I'm lying. So the general definition, just the probability that a software system will not cause failure under specified conditions. We can't just generically ask about failure because it's not well defined, or it will be a problem specific definition. So total uptime, how long will elapse until the system will fail on average? So in any online game, there's going to be some bug that exists that causes the realm to crash, or causes an instance crash, or causes some kind of crash. If you were to analyze thousands of years of playtime data, what would the average amount of time be before a crash that caused the game to crash, the server to crash, some other kind of failure? So you can also look at the crash data to say what caused that failure. So the reliability can be hidden in the crash data of how severe was the crash, what happened, how do we recover from that? So the two main metrics are uptime, mean time until failure. We have about 12 minutes left. What other questions can I answer? Yeah.
So, in an industry, when you do a test, then you find a bug, you send it to somebody else to fix it, or how?
It depends. So frequently you're actually going to hire quality assurance testers whose job it is to break things. This is the child who is always just smashing things for fun. They grow up to be quality assurance testers. They will play around with a software system and just start trying to break it in whatever way, shape, or form they can. And then they will report things like, here is what I did, and here is what I saw. And then usually as a programmer, you're going to receive these logs from testers. So you're going to create the reporting system. You can do this as a game, and continuing to use a game as an example, and an alpha or beta test. Usually you have some kind of debug chat log or some kind of command that captures a bunch of information and sends that on as a report. And then people whose job it is to go look at the code, they're going to have just a consistent stream of bug reports to be able to clarify or answer what kind of bug was this? Can I go reproduce it? Can I go fix the bug? So usually there is segregation there between those ideas where the person who's trying to find the bug is not the same person as the person who is trying to fix the bug. But the smaller the company, the more overlap between these roles we have. So if your company is just you, obviously you're doing everything. If your company is 3 people, then you don't have that level of separation of concerns. If your company is 10,000 people, now everyone has a very, very specific role they're supposed to be an expert at. But then in a company that big, there has to be excellent communication standards between all of these people and departments so that stuff actually gets done and communication happens.
So for timeouts, would you just want to justify them if you could run into like an infinite loop?
They're usually so easy to implement that
You want 'em-
you just want them everywhere on every test that you write.
There's not really a time where you can not use one.
Yeah, the only time when a timeout is bad is if you set a number of milliseconds that's less than than it can actually reasonably take.
Mhm.
So setting 2 seconds or 5 seconds is generally fine. And you can, especially with complex systems, you can get stuck in loops that you did not anticipate. Like, I communicate with you, you communicate with me. I take that response and communicate with you. And it's not a loop. It's just the call and response that you've built into something. So yeah, you get logical loops in a lot of places that aren't specified. So just having that timeout, you would critically be able to analyze and say, why in the world would this test take longer than 2 seconds? I never imagined this test could possibly take longer than 2 seconds. And it will identify a bug that you never knew was there, that you didn't think that you would need to fix without putting that timeout on that test.
So it's good practice to have a time on
Yeah.
every single test.
Yep. What else can we talk about? This has been great. There have been lots of excellent questions. I've definitely had classes before where we just get in these awkward staring contests because nobody has any questions. And then they take the exam and they go, darn, I should have asked a bunch of questions ahead of this.
Do you expect us to write actual code or just a pseudocode?
There may be some actual code.
But is it like walls of text code, or just like a couple of lines?
So for this class right now, I would expect you to be able to write tests for things. So I'm probably not having you write implementation. We haven't really talked about a ton of implementation related things, but I might ask you something very similar to this exercise, where it's something like either here's an interface, write tests for this interface that guarantees certain levels of functionality.
Yeah, you can assume that those things work as intended, right?
Yeah,
And just like, you have to test, you have to test to ensure it works reasonably well.
and then I also might give you actual code and say, write the tests for that code. But since the entirety of this exam is based on tests, I would expect that most of what you write is going to be tests and not logic. Because logic shouldn't be embedded in tests anyway, right? We wanted to factor that out as much as possible because we shouldn't be writing loops or if statements in our tests.
Also, how about infinite loops if you're doing a math project?
It can be really bad.
How about from a little annoying to disastrous?
All of it. Depends on the implementation. Depends on what you're making. If you're caught in an infinite loop and a loop is supposed to go some number of times before a certain medication is delivered automatically to a patient, and it gets caught in an infinite loop, then it never gives you steps into know that this.
Oops, somebody's dead.
So I can think of plenty bad experiences where an infinite loop could cause arbitrarily large problems.
For the dot equals and equal, would like the dot equals be like if you're using like a wrapper class instead of a primitive?
Yeah, well, whenever it's an object that can't be compared, equals is only for primitive comparisons like int to int, double to double, character to character. But as soon as you have an object, objects have to be compared with an overloaded dot equals.
For the questions like how do we know a program works, how detailed do you expect this?
That's a good question. the level of the slides would be about an appropriate level to strive for that. You can, of course, add on any additional thoughts that you have about that, but my expectation can't be, I gave you this, I expect significantly more than that. I expect at the level that I have delivered for class.
What question was that for?
For,
How do you know the program works first?
yeah, how do we know a program works? Well, the answer is we don't.
Yeah.
Ever, really, but we can get a better idea that it works sometimes, or we can guarantee that it works under certain conditions with unit tests. For more than that, we actually have to go look at formal logic and try to get theorem provers involved. And basically, if you've taken or are taking discrete, all of the proof types that you use for that become very valuable for ensuring that your program actually does what it's supposed to do. But you have to abstract it from testing very specific examples to now using generic logic. All really good questions. We have 4 more minutes, I think, if there's anything else I can answer.
Cases.
Yeah. So logically, we determined something like a Boolean logic, the change between something like less than or equal to. You want to test something that is less than, you want to test something that is equal to, and you want to test something that is greater than. The less than and the equal to should succeed, the greater than should fail. But you want to test things that are close to that boundary because those are the most likely cases to be wrong. If we're testing equals, we don't want to test something that's drastically different. We want to test something that's pretty close to equal, but not equal. And then something that is actually equal. Whenever you write these tests, you want to be thinking about what are the ways that we want to identify the most likely ways that it can fail. That's a better way to say that. And test those. So thinking critically about when is this going to not work? Or when is it possible this could not work? That's what you want to write a test about. Seeing your test fail is a beautiful thing.
Is that good or bad?
That's great. It means you found something. If your tests all succeeded, that bug would still be there. If you write quality tests, you'll be aware of a bug that you wouldn't have been aware of otherwise.
But then this says that you have to know where the code could happen, right?
But if you wrote a really good test,
But test
Then-
is that, so like this thing will cause this to fail, but if you have multiple places in your code that fail can happen, then what's hard to tell?
you have to go play around with it.
But you know, at least you know what type it is.
Right, exactly. You know, some instance of some failure that you can now try to reproduce. You can go into your debugger and you can look at what was the state of my program right before this happened. That can help you. Anything else? We do still have a couple of minutes. If anyone has any other questions?
So for the problems or for the bugs that cannot be reproduced,
Yeah,
the, do they just document and leave it as is, or?
yeah, you usually document it. If you're in industry and you can't identify it, then you would need to document this issue. You throw that report in a specific folder of bugs that haven't been identified. And then you usually have a different hierarchy of people who have different levels of expertise, and all the way up there, you have, you know, some expert bug finder. And then you're just gonna basically send it on up the chain. You're gonna have 10 employees who are basic Java programmers who can go attempt to find it and fix it. If those 10 people can't do it, then you feed it up to their manager, who, there's only one of them, but their time is very valuable. You don't want them fixing things that the grunt workers down below could have fixed as well. So something like that. Companies are very good at structuring for stuff like that, to not waste people's time. Try to build in that structure. All right, I do have to run off to a meeting, so I usually have 1 o'clock office hours, and this is the last day I'm gonna have to cancel these. But if you have any further individual questions, feel free to shoot me an email. I will get back to you on that before tomorrow's exam. And if you think of any other questions, let me know. I'll be around for office hours the hour before the exam as well. So if you have any other last minute questions, feel free to stop by. See you tomorrow.
Yeah, I mean, wondering, like, so something simply, so. We just, it's water bug, and the water bug is like, like, if it goes, 50 breaks. That's all.